This is a demonstration of the proper setup of a ring and pinion gear set in the rear differential of just about any vehicle out there. This particular differential is out of a 2007 Toyota Tundra pickup truck with a 10.5-inch ring gear. We have right here a couple of examples of pinion gears. The pinion gear itself, right here, this is the pinion gear out of an axle just like this, and we have a pinion bearing in the rear and a pinion bearing that's going to go in the front with an oil splash shield, and then your pinion flange that your U-joint hooks to, and then the nut. In between the two pinion bearings we have a spacer with a couple of selective washers. Right here there's two washers that you put together in certain thicknesses to control the spacing between these two bearings. The spacing between these two bearings, when you tighten the pinion nut down on this particular axle, is going to give you a certain rotational torque on the pinion gear itself. So we have this exact setup installed already in this housing, and the rotational torque with the pinion nut tightened to specification needs to be measured with an inch-pound torque wrench. The inch-pound torque wrench, this particular one I have, goes from 0 to 30 inch-pounds, and of course it takes 12 inch-pounds to equal 1 foot-pound. The specification for the rotational torque of this particular axle is 13 to 19 inch-pounds of rotational torque. So as I rotate this with this inch-pound torque wrench, I can read whatever the specification is, or I'm sorry, read whatever the torque wrench is telling me. I'm going to need this type of a dial torque wrench or a flexible beam torque wrench. The clicker style torque wrenches or the beeping, vibrating type will not work for this. It's very important that we get the proper rotational torque set, because that is what's called the bearing preload. We're going to put a load on those bearings that's going to hold the pinion gear from moving when we are driving down the road, because the pinion gear will want to move towards the front of the vehicle when you accelerate and towards the rear of the vehicle when you decelerate. Well, we don't want that to move at all, so we have to put the proper load on these bearings, and that load on this particular type of axle is controlled with what are called preload shims. Now this pinion right here is out of a different axle, and instead of having preload shims, we have what's called a crush sleeve. And this crush sleeve goes between the two bearings. It's not reusable, and the crush sleeve is a certain height when you first install it. And then you're going to put the pinion bearing, the oil slinger, the pinion flange, and the nut on, and you're going to slowly tighten the nut until it hits the crush sleeve, and you slowly tighten it to where it crushes the crush sleeve and gets to a point where we have that same rotational torque. Now every vehicle manufacturer is going to have a certain rotational torque specified just for the pinion gear itself. The pinion gear, the pinion bearings, you must have the pinion bearing preload set properly before you can move on to installing the ring gear or the differential case or any other parts. Nothing else matters right up front until you get the proper bearing preload on the pinion gear itself. And it's done typically one of two ways. One way is with the crush sleeve, and another way is with bearing preload shims that you put together that come in a variety, probably 30 different thicknesses, and you're going to add the two together to get the proper distance between the two bearings. Now, once you've gotten the preload set properly, then we can move on to installing the ring gear. So I'll turn this housing upside down. Get these pinion gears out of the way. This is the ring gear out of this particular Toyota Tundra pickup truck. We have the ring gear itself, we have the differential gears with the two side gears, the two differential pinions. We have on this particular axle, these side bearings are going to have bearing cups that are going to sit down on both sides, and then those bearing cups are controlled as far as how far in or out they go with shims. And these shims come in a variety of different sizes. These shims are what is going to control two things. The first thing is the load on the side bearings itself. We need to compress or load these bearings and put a preload on them so that the differential case isn't moving all over when we accelerate and decelerate driving down the road. So I'm going to install this right now. We've got the shim that goes on the one side, and then we've got a shim for the other side. These shims are not just going to fall into place. As a matter of fact, I probably ought to put this other side in first to show you what I'm talking about. Let me get that one out. We'll move it over. Get this shim in first. Okay, it's down in. Now this shim has got to fit down in the housing also, but the reason it doesn't just fall right down in is because it's actually got to put a load on those side bearings, and so we have to carefully tap it in place to where we don't damage it, and that's going to put the load on the side bearings itself. One way to do that is, if I can get it out all together here, kind of put it in as an assembly on both sides. Easier said than done. And then use a plastic hammer drive it into place. We don't want to use a steel hammer. We don't want to damage the bearings or the spacers. And we'll put that down into place. So these shims, once again, they're actually going to control two things. The first thing is the preload on the bearings to keep the ring gear from moving back and forth as we drive down the road. The second thing is these shims are used to control the backlash. I don't know if you can hear that, but there's a backlash that has to have some space in between the ring gear and the pinion gear itself. And that backlash is measured with a dial indicator, and we'll do that here in a few minutes. But as long as we have backlash right now, we can put the bearing caps on, and the bearing caps are left and right specific. I've got them marked as to which way they go. So I'm going to put these bearing caps on and tighten them down. We're going to torque the bearing cap bolts to specification, and once those bolts are torqued to specification, then we can turn it over, and with that same inch-pound torque wrench, we're going to measure the bearing or the pinion bearing preload again. But this time it should be more because we've added the preload of the side bearings, and the pinion gear has got to turn the ring gear, which is held in place by these side bearings. So I'm going to tighten those down and turn it over and take a measurement. Okay, I've now got the bearing caps torqued down to specification. We still have some backlash. I don't care how much the backlash is right now, as long as I have backlash. And now I'm going to turn the axle over in this holding fixture and use the same torque wrench and measure the preload again. And now the specification in the book, and it's different for every vehicle manufacturer, so look up what yours is, but it should be whatever the pinion preload was when we first started, plus a little bit more for the side bearing preload. On this particular axle, it calls for 2 to 3 inch-pounds more of preload as measured at the pinion. But this gear ratio is 4.30 to 1, a 430 to 1 gear ratio. And that makes it 4.3 times easier to turn the pinion than it is to turn the ring, which means the actual preload that we added to the side bearings is 4.3 times higher than what we measured here. So let's say we added 3 more inch-pounds of torque as measured on this torque wrench. 4 times 3 is 12. 4.3 times 3 is 12.9. So we've added about 12 inch-pound, 13 inch-pounds of side bearing preload on the side bearings here. So let me turn this over. If that's within specification for your particular axle, then great. You don't need to change the shims anymore to tighten the bearings down to increase the preload. However, what we need to do next is to measure the backlash. Once our bearing preload is within specification, which this one is, but if it weren't, we would just change those shims equally to a thicker shim on each side. The next thing we need to do is measure the backlash. So I'm going to get a dial indicator and hook it up. Okay, I now have a dial indicator hooked up. We want to have the dial indicator for measuring backlash be at a right angle with the gear tooth as much as we can. So the plunger is going to come down, the gear tooth, we've got a flat spot on the gear tooth right here, and we want to be on a right angle. Now the dial indicator is going to, as we move the ring gear back and forth, indicate our backlash. We're going between 0 and about a -4. That's 4/1000ths of an inch backlash. The specification on this truck, I believe, is anywhere between 4 and 7/1000ths of an inch. Every vehicle manufacturer is going to have a different backlash specification, but most of them are somewhere in that 4, 5, 6, 7/1000ths of an inch area. Now, the backlash that we're measuring here is just on the one tooth, and it's not this tooth where we've got the dial indicator. It's the actual tooth that's down touching the pinion gear itself. And you should never just rely on the backlash reading of one tooth. We can't measure this one tooth and say the backlash is the same on every single tooth. There are 43 teeth on this ring gear, and out of those 43 teeth, can you guarantee without measuring that every single gear tooth has equal depth, which will give us equal backlash? There's no way. And so at bare minimum, the Toyota manual says measure in at least 3 places. But if you're hunting a noise or a vibration, remember the ring gear turns the same speed as the tires. And so if you had a noise or vibration that seemed to be tire speed related, you may actually want to check the backlash on all 43 teeth. I know that's a lot of work, but it only takes one gear tooth to have no backlash at all, or even negative backlash, where it's binding up to cause a noise or a vibration. Now, there are 2 types of ring and pinion gear sets out there. There are ring and pinion gear sets like this one, where the depth of the tooth is equal all the way from the heel, which is on the outside of the tooth, to the toe, which is on the inside of the tooth, and that one is called a face hobbed gear tooth, where it's equal depth all the way in. Other older ring gears, at the toe side, the depth of cut on the gear tooth is less than it is out here on the heel. So it's real deep at the heel, in at the toe it gets more shallow, and that's called a face milled gear set. So there's face milled gear sets, which are the older ones that are unequal depth, and there are face hobbed gear sets like this one, where it's equal depth all the way in. Well, that's a difference in manufacturing procedures. On a face hobbed gear set like this, all the gears are ground at once. There's a cutter that comes in and rotates at the same time the gear rotates, and it cuts each individual tooth all at once as it rotates. Where a face hobbed gear, each tooth is cut one at a time. I'm sorry, a face milled gear, each tooth is cut one at a time, and they can actually be or have some differences depending on how old and worn out the Gleason machine is that cuts those gear teeth. And so I tell you this because it's important to know the difference between those two gear sets, because our next step is going to be to paint the gear teeth with Prussian blue or some sort of gear marking compound and look at the contact pattern. Now, everything we've done up to this point, we've set the pinion depth or the pinion preload. Oh, I forgot, there's a pinion depth shim. In between the pinion bearing and the pinion gear is a shim called the pinion depth shim. That shim controls how far up in this housing that pinion gear sits. And our contact pattern check that we're going to do is going to tell us, is that pinion too high, too low, or is it okay? It's also going to tell us, is our backlash too tight or too loose, or is it okay? Now you might be thinking, well, of course it's okay, it's within specification. But that, just because it's in specification does not mean it's set up correctly. What you need to remember is that as long as your bearing preloads are set correctly and your backlash is set correctly, then you can paint your gear teeth and run the contact pattern check. But that contact pattern check is what's going to tell you whether you still need to adjust the backlash, the back and forth movement of the ring gear, or if you need to change the pinion depth with that shim that I told you about, which is a real pain because you got to totally disassemble everything. You're going to ruin the pinion sill. If it's a crush sleeve type axle, you'd have to replace the crush sleeve again because they're not reusable. But up to this point, our pinion bearing preload is correct, our side bearing preload is correct, our backlash is correct, and so the next thing we're going to do is paint the gear teeth and run a contact pattern check. One thing you should also do, because it's adjustable, is down here in the differential itself. Now remember, there's two sets of gears in a differential assembly. We've got a ring and pinion gear set, but then we have the side gears. Turn it. Right down in here, we've got the side gears and the differential pinion gears. There's a backlash measurement on those that I have a different video on YouTube. It's called Measuring Differential Gear Set or Side Gear Backlash. We're not going to do that in this video, but that backlash is just as critical as this one for proper setup of the differential. So I'm going to paint the gear teeth up. What I'm going to do is paint every single gear tooth. The convex side of the tooth, the part that sticks up, is the drive side of the tooth. The concave side, the side that caves in, is the coast side. So we have a coast side and we have a drive side. We're going to paint both the coast and the drive side of the gear teeth and then look at the contact pattern. I forgot to mention one thing on our backlash measurement. If our backlash was incorrect, we would have to change those two shims on the side bearings let's say we wanted to move the ring gear closer towards the pinion. We would have to put a thinner shim in on this side of the side gear and a thicker one on this side by the same amount. Let's say we wanted to add subtract 2/1000ths of an inch from this shim over here and add 2/1000ths of an inch over here. That would bring the pinion over closer to the, that would bring the ring gear over closer to the pinion. If we want to move it away, we would add a thicker shim over here and a thinner shim over here, and there are a couple of dozen different sizes of side gear shims. But remember, we've got the bearing preload that has to stay the same. As long as we change the shim thickness by an equal amount, we subtract 2/1000ths here, we add 2/1000ths here, our side bearing preload will still be okay. Okay, I have painted some of the ring and pinion gear set, or some of the ring gear, I'm sorry, with two different types of gear marking compound. The yellow is pretty standard in the industry. This particular compound is Mopar or Chrysler gear marking compound, but it's the same as General Motors and some generic gear marking compounds. The yellow iron oxide based gear marking compound. And then you can also get what's called Prussian blue from Permatex, which is what I painted here, the darker teeth. Now, to run a contact pattern check, the gear actually needs to be loaded. In other words, it shouldn't be just a free spin of the pinion gear and ring gear, because there's no load on the gear itself. We need a good solid load on the ring gear to be able to have a good contact pattern. Well, if it's a typical rear axle that doesn't have a removable differential housing like this one, where the housing stays in the vehicle, you can put your axle shafts in and ride the brakes, and you'll have to use a wrench, a socket, and a ratchet to turn the pinion gear. You want to turn it forward and backwards so that we get both the drive and the coast side of the teeth for a contact pattern check. On this particular type of axle, I'm not aware of a way to load it heavily other than to come in with a pry bar and kind of pry against the ring gear at the same time that somebody else, see, we'd want to go the other way, is turning with a wrench the pinion. So if I pry against the ring gear, then it's going to make it harder to turn, and that would be loaded as far as I could get it in this particular type of axle. I know Ford has some axles like this. Chrysler, older Chryslers and GMs had some like this. This is Toyota. Nissan has some that are similar. But I'm going to, in this demonstration, since it's, I don't have a way to load it properly, I'm just going to rotate the ring gear around just to get a contact pattern. It won't be a valid pattern because I haven't loaded it, but I've run it one way. Now I'm going to run it back the other way, and if that had been loaded, if I would have had somebody here to help me load and turn the ring gear, then we can come in and take a look at the contact pattern next, and I'll need to zoom the camera in for that. Okay, we've repositioned the camera so we can get a better look at the contact pattern. I'm going to zoom in even more here, and I want you to see right now we are looking at the coast. Well, let's see, right here we're looking at the drive side of the gear tooth, and the contact pattern kind of starts in the middle and works its way back. It's fairly centered on the drive side of the gear tooth. If it was more towards the toe, we would want to make an adjustment. If it was more towards the heel, we would want to make an adjustment. But if it's centered, which is what we're looking for, then that's a great contact pattern. But we need to look at more than just the drive side of the gear tooth. We have to look at the coast side also. So let me bring this up a little bit more. If we look at the coast side now, this back side, notice it's also pretty centered. It starts about right here and ends about over here on the coast side. That's as about as good of a pattern as you're going to get, which means the shims that are in the side bearings here that control the preload and also control the backlash are correct, and the pinion depth must be correct. But let's take a look at, or let's go through some examples of incorrect contact pattern and see what we do for that. Remember on our gear teeth, out here on the end, this end here is the heel, and this end is the toe, and then the drive side right here is convex, the coast side right here is concave. If we had a pattern that was on the toe on the drive and on the toe on the coast, that tells us that the backlash is too tight and we would need to loosen the backlash. If we had the contact pattern out here on the heel on the drive and the heel on the coast, that would tell us that the backlash is too loose and we have to adjust the backlash to get that pattern here in the middle like we've got it on this axle. If we had on the drive side the pattern was too close on the drive on the toe and too close to the heel on the coast, then that's a pinion depth problem. And that tells us that the ring or the pinion gear down in the differential case is up too high. If on the coast side the pattern was on the toe and the drive side the pattern was on the heel, then that tells us that the pinion depth is too low, and that shim that goes in between the rear pinion bearing and the pinion gear itself is what we adjust to change the pinion depth. Some axles have a pinion depth shim behind the bearing race rather than on the bearing itself on the gear, but either way, the contact pattern is the final say of what we do with the ring and pinion gear set to see if it's set up properly. But remember, you should not run a contact pattern check unless your bearing preloads, all your bearing preloads, your pinion bearing preloads, your side bearing preloads are first within specification, and then your backlash is within specification. Then run your contact pattern check and see where the pattern tells you to make the final adjustment. This particular one is set up just right. If this were the loaded contact pattern, this would be ready to put back in the vehicle and drive. But if you put one back in that does not have a centered gear set or gear marking with a gear marking compound, a gear pattern, contact pattern, it could make noise. And it might make noise while it decelerates, it might make noise while it accelerates, it might make noise all the time, just depending on how it's set up. And I'll have a chart you can download through our Weber Automotive website to interpret these gear patterns. And so this has been a demonstration of the proper setup of a ring and pinion gear set. Look for my other video on YouTube for a differential gear set backlash adjustment, and good luck with your differential overhauls.